Hello, my name's Robin Vincent and welcome to Molten Modular. Today we're investigating how to get control voltage into and out of your computer and into your Eurorack. Can you do it? Can you control one from the other? Can you suck CV out of your Eurorack into your computer? Can you generate CV from your computer and stick it into your Eurorack? Well, the answer to those questions is yes. And for the purposes of this video, I'm going to be using Bitwig 2, which has got some very interesting CV generation facilities in it, and my Surface Pro here as my computer doing its job. Now, the thing that pulls this all together is something called DC coupling. Now, that's a function of your audio interface. Audio interfaces will either be AC coupled or DC coupled. What the hell does that mean? Well, it simply dictates what signals can flow through it. An AC coupled audio interface will only allow AC signals, so these sort of signals, audio signals, that are going up and down like this. So an AC coupled audio interface will only allow audio signals through. A DC coupled audio interface will allow flat signals through, which is what control voltages are. They are flat DC signals. So in order to be able to use CV successfully from your computer to your Eurorack, you need a DC coupled audio interface. Now, you can also do it with an AC coupled audio interface, but it's more difficult and requires a little bit more thought and extra stuff. So I'm going to do an entirely other video on that so that we can focus on that directly. But for the purposes of this video, we're going to be dealing with DC coupled audio interfaces, because that by far is the easiest way to get CV between these two devices. So why is there a difference? Why do we have AC coupled audio interfaces and DC coupled audio interfaces? Well, very simply because it's to do with what your audio interface is trying to achieve. I mean, normally speaking, you just want audio signals, and so a manufacturer will design their interface to exclude or filter out anything which isn't an audio signal. So when something is AC coupled, it has a high pass filter in it to filter out those lower static or low frequency DC signals. And that's right, it should do that. That's correct, because you don't want those creating interference. What do I mean? Well, if I just take a little bit of blank paper here, what I'll do is I'll demonstrate this very simply. I'll draw a graph. So this is the input to our sound card, if you like. Here is peak level, amplitude, time going this way. If we have a normal audio signal going through our audio interface, it'll look something like that. Just a standard wave, nothing too flashy. That's good, we can record that, no problem. If a DC signal is also present, say like that, and that's going to be flat, it's not going to be moving about normally, what happens is that these two signals present in this audio interface get summed, they get added together, and we get a resultant waveform which is like this. Now, it's still the same as the original audio signal, but it's been boosted, it's been added to it, it's had this constant voltage added to it, so now it's louder, it's bigger than it was, and there's the danger that that's going to go past the peak point and result in distortion. So that's why we don't want that there. We want that filtered out so that the audio that comes into your audio interface stays at the right level and is free from distortion. Does that make sense? There's probably a ton of other reasons, but that's the one that seems to work in my head, that a DC voltage will add voltage to your audio signal, therefore causing distortion. Got it? Good. So an AC coupled audio interface is one that's going to filter out that DC voltage. A DC coupled audio interface is one that's not going to filter out. So there's perhaps that risk of what we call a DC offset, which is adding to the signal that's coming in. But if the rest of your gear is fine, then that really shouldn't be an issue. And the great thing for us is that we can use that sort of audio interface to route control voltage into and out of the computer. Yay, that's what we want to do. Great, so let's go and get a DC coupled audio interface. Now, that can be a bit of a problem because they are rather thin on the ground. But hopefully this is changing. The PreSonus Quantum, their new Thunderbolt audio interface, has DC coupled outputs. Some of the RME ones do, particularly the headphone outputs, for some reason, tend to be DC coupled. Avid audio interfaces for their Pro Tools HD systems, they tend to be DC coupled also. Motu a lot of their interfaces are DC coupled, although apparently, so I'm told, it's by accident, not by design, because they forgot to put the filter in. But all of these are quite, big pro high-end audio interfaces, and I've struggled to find anything more sort of low-end that I can use in a sensible way in my situation. One of the more interesting options is from Expert Sleepers. They do seem to be the expert in this kind of thing, and they've released a module for your Eurorack called the ES8, and that's a full USB audio interface with proper drivers and everything to which to connect directly to your computer. And that will give you 8 CV outs and 8 CV ins, all DC coupled and properly running directly into your Eurorack. And that's awesome, that's great. But the problem I have with that, I guess, is that you lose a lot of the features that you'd normally want from a regular audio interface. So I'm talking about microphone inputs and outputs and headphone sockets and other bits and pieces and connections that you want to have in your audio interface. The ES8 doesn't have any of those things. It's only really great for sending CV in and out. However, they have another one which is an ADAT to CV module. So if you have a spare ADAT output on your audio interface, you can route that to their ADAT to CV converter and have 8 DC coupled outputs directly into your Eurorack. I mean, that's probably, as far as I can see, the most ideal situation. However, I don't have an audio interface with an ADAT output either. So what do I have? Well, I found this little fella. This little fella here, the Roland Demora. It's part of the Aira range of modules that Roland do. It's great. It's a proper Eurorack module. It goes in your Eurorack, and this one provides a delay and other stuff. It has some really interesting editing software which allows you to patch together all sorts of stuff. So it's a decent Eurorack module, while at the same time it has a USB connection to my computer, which also comes with ASIO drivers. And would you believe it, the inputs and outputs are DC coupled. So with this little Eurorack module, I have suddenly found for myself a DC coupled audio interface. How awesome is that? I mean, there's only 2 in, 2 out, which you'll see will become a problem at some point. And also, it's not entirely perfect. It has one flaw in it, which makes certain things quite difficult, but I'll get onto that in a bit. But for the moment, for demonstrating what I'm trying to do, trying to get CV in and out of the computer into my Eurorack, this, as a DC coupled audio interface, is going to do the job. And hopefully I'll be able to show you exactly how cool that is. One last thing, why not do this with MIDI? Why far around with all of this trying to get CV from one place to another? Anyway, can you not get a MIDI to CV converter and then just take MIDI out of your DAW into that, CV into your Eurorack? Yeah, you can do that. That's probably easier. Yeah, do that. Or not. I mean, it really depends. You can do a lot of the similar stuff with a MIDI to CV converter. You can indeed take notes out, stick them through that, and then CV through the rest of your rack. But I think what's interesting about CV is that it just works differently. If you're committed to using CV within your Eurorack in understanding control voltages and how they interact and move with each other, then I think it's better to have that going directly into your computer, because you get the same level of control. You get the same stuff going on. You're not going through some kind of digital conversion to approximate the same settings and the same sort of control. It probably is easier doing it via MIDI, and would you really notice a difference, or would you feel hampered if you were? I don't know. But what I am trying to do is to deal with control voltage. I'm trying to get that into my computer and out again. I'm trying to see what these devices in Bitwig can do and what sort of creativity they afford to me as someone who's trying to dabble in analog signals and Eurorack and control voltage and modular synthesis. That's what this is all about. So yeah, go do your MIDI thing. That's fine, go do that. But that's not what I'm going to do here. I'm going to get stuck in to trying to tease CV between these 2 devices. So let's get on with that. Let's bring our focus then to the tools on the table. So here is my Demora. Of course, it doesn't have to be a Demora. It could be any of the Aira Roland modules. They all act the same way, work in the same way, have the same software and drivers, etc. This is connected via USB to my Surface Pro 4. First thing you need to do is open up the Aira modular customizer software, which is this thing here, and remove any of the other modules which are loaded into the device, because this is very customizable. You can put in all sorts of things like filters and delays and choruses and other effects and CV loveliness all within this module, but none of that's going to help us if we're just trying to get CV in and CV out, because it will change the nature of that control voltage and the nature of the signals going through it. We don't want any of that. We need to remove it and have it completely plain. Then in Bitwig, we set it up as ASIO, Aira, Modular. I've created a Demora in 1 and 2, and an out 1 and out 2, and also a stereo out. And it's important to remember that when we're using this for CV output, we're not going to be listening to anything that Bitwig's doing. I don't have any additional outputs to run audio from Bitwig. We're not interested in that. In this particular case, what we're doing is trying to get CV out of Bitwig into the modular. That's our first task. So how do we do that? Well, Bitwig 2 has these very interesting CV generators inside. Let's have a look. I'm going to add a track in Bitwig, hit the plus button, scroll down here, and we will find under HW CV a couple of options. One of them is for instrument, which we'll look at later. The one we want is HW CV out. Load that up. So what this gives us is a ridiculously simple CV generator. It's just a knob. It's a knob which generates a control voltage, and the little graph here shows us exactly what sort of signal it's generating. I can move that up and down, la-di-da. Awesome. All it needs to know is where to send it. So we can select an output here, Demora output 1, and now this control voltage is going to come steaming out of this output. So let's plug that in to try to show that. Now I've got a little scope in my rack here, which you may have noticed is an addition to my rack, and this is hopefully going to show us what's coming out of Bitwig. So at the moment it's set to about nothing, and as I move this up, you can see there's a red line there which is demonstrating the control voltage. That's fine, but this is Bitwig. We want to stick in some modulators. We want to get this CV moving about so we can use it to control stuff. So let's bring up the modulators. Let's hit that. Let's go for a classic LFO. Stick that in. Now we need to map our modulator to our CV knob. So let's hit that. Move that up a little bit, and that's now controlling our CV knob, and you can see in the meter here this is now going up and down. I could probably adjust this so that we can see it in a different way. There we go, look, it looks like a wave and stuff. So we have our modulation signal here, our modulator modulating our CV, and this output from Demora going into our scope, and you can see it happening there. But let's make it move something. So let's attach it to the output from here, because this just goes straight through, and we'll stick it into our filter. But first of all, let's hear our sound. This is from over here, our wavetable oscillator. And I've got it running through this filter. So we're now going to modulate from Bitwig. So that was easy. So the CV from here is coming out of the Demora through my scope into the filter. Modulating the cutoff. Easy peasy. Right, well let's add a second one. Another CV out. Put that there. We're going to set that to output 2. So output 2 from here going into my scope. So again we can see what it's going to do. This time the modulator I'm going to add will be the random one. I like that a lot. So again I'm going to assign that to this. I'm going to perhaps make that move a little bit faster. You can see also in the scope, hopefully, you can see the random voltages that are being generated by the CV generator in Bitwig. It's now going through the scope, and I now want to plug that in to something interesting. So let's take that. Let's hear our sound, and I'm going to plug it into the wave on the wavetable. So now I have the random affecting the wavetable choice, and I have this one affecting the cutoff here. And of course I can slow this down, speed it up, whatever. Oh, I could change it to something else. Let's add a stepped one. So I've now got a sort of a step sequencer affecting the cutoff frequency on here. All sorts of things. Let's have some envelope action. Stick that into there. Stick that one into there. And so on. So that's two CV generators from Bitwig coming out of my Demora and modulating my Eurorack. Simple, and you can add whatever you like to this. You could draw in automation, you can sync it to your project or have it synced up to a sequence. You can have modulators automated or modulators modulating modulators that then route that resultant CV out and into here. You can molt this up, so you can stick it into a molt and then send it to different destinations all at the same time. This is just using two outputs, so that's all I've got. I can send two control voltages out with this particular setup. But hopefully that demonstrates just how simple and beautifully simple these are. It's not complicated. It doesn't have to be complicated. There are some plugins, for instance, the one that's used most often is Silent Wave from Expert Sleepers again. But actually the plugins in that are quite massively complex. And when you're actually just trying to achieve something quite simple, then this CV generation in Bitwig is completely awesome. Right, okay, well let's go the other way. Let's take a modulation signal from the Batumi and do something interesting in Bitwig with it. Yes, great, let's do that. So first of all, I'm going to delete that track just to get it out of the way. And I'm going to create a track with the polysynth, like so. Now, of course, we can't hear this. In fact, if you can see here in the scope as I press things, you can see there's a little bit of activity going on. That's because this is sending audio out of this. Now, if we're going to bring CV in, then we want to be able to see or hear what's going on in Bitwig, so we're going to need to be able to hear it. So rather than sending CV out of here, I'm going to send audio. So I need to take my audio outputs, plug those into here. So there we are. I'm just going to boost that up a little bit so we can hear it. Great, so now I'm going to want to modulate this from my Eurorack. Of course Bitwig's got a load of modulators built in, that's fine, but we're talking about this CV integration Eurorack into Bitwig. So to do that, what I'm going to do, I'm going to take the output of a Batumi here, which is my LFO, my lovely LFO, take a sine wave out, and I'm going to plug that into input 1 on the Demora. Now, in order to get this input into Bitwig, I need to load another modulator in here which can understand and take hold of that signal. So I'm going to add a modulator, and there's one here called CV in, which comes up as this nice little plug. Now it has to know what input is being used, so we select input number 1. And there you can see is the modulation coming in from the Batumi. If I take it out, it's disappeared. Put it back in, there it is. So now I have modulation from the Batumi coming through the Demora into Bitwig. And then all I need to do is map it to something. So we'll turn on that, go to our old friend the cutoff, I suppose. So that's now bringing control voltage from the Batumi through the Demora into the polysynth. So let's take another sound. Let's add our modulator to it. Hardware in. Demora 1. Slap that onto our cutoff. And there you go, there's CV coming from here into here. Now you may have already noticed that there is a slight weirdness going on. But I'm going to demonstrate that perhaps a little bit better when we get to the next thing, which is to get notes out of Bitwig into our Eurorack. That's the next challenge. Let's do that. So our final task is to get notes from Bitwig into our Eurorack, to get sequencing from here, playing our hardware modular synthesizer. Let's add another track. Let's go down here to hardware CV instrument, that one, HWCV instrument. It's that which generates the CV, the pitch and gate information we need to run our modular. Let's have a look at that. So we have pitch and gate output over here. That's the first things we need to set up. So pitch out, we're going to go to Demora out number 1. So that will be this cable. It goes from there into the scope, and then we're going to use it on the 1 volt per octave input on our ST0. Then gate output here goes to Demora 2. So that's this one, which is currently coming out of there into our scope just for fun, and that's going into our gate on our VCA there. Then we finally need the output from the STO going into something useful. So then when we play, we can play our modular. Hooray! Now, something you might notice at this point is that this is C3, this is C4. It doesn't really sound particularly in tune. Yeah, that's because it's not. The Bitwig instrument here, the CV instrument, needs to tune itself to the oscillator in your Eurorack. Now, this is kind of where it all starts to pull down, really, but we will endeavour to push forward, because if you have a good DC coupled audio interface, then this is absolutely no bother. If you're using an Aira device, as I am here, bother starts to sort of creep in, rather. But let's just continue. What you need to do, what needs to happen, is that you need to take the output from the oscillator into the Bitwig device. That way it can sort of detect or pitch detect the incoming and tune itself against it. Does that make sense? So to do that, and to be able to hear the oscillator all at the same time, the only solution I can think of is that you need to put it through a mult. So I'm going to take the output of my oscillator, stick it into my mult over here, then take one of those out, back into this filter here so I can hear it. Yeah, we can still hear it. And another output from it we're going to have to take to the input on the Demora, like so. And then we need to select that here, input number 1. Now you may notice that my scope is kind of going a bit crazy. I've also got a very hot input coming into here. It's because of my Demora is all a bit too turned up for when I was listening to it as an audio interface. A moment ago, to listen to the audio, I needed to turn it up. With the control voltage, I need to turn it way down because there's far too much stuff coming through. Good, so I've got pitch and gate, and I've got the audio signal from the oscillator coming back into Bitwig so it can tune it. Now I need to press this big tune button here, and it should, hopefully, sort itself out. Okay, awesome. Now it took me a little bit of time to get that sorted out, but I now have at least 3 octaves of tuned oscillator. Can you hear that? And this has changed in order to reflect what it could detect and what it could sort out. Now the reason I'm having a little bit of trouble, because this normally on a proper DC coupled audio interface works perfectly. The difficulty that I'm having is that the inputs and the outputs of the Demora are hardwired together. So whatever's coming in the input gets passed directly to the output, which makes sense because it's a Eurorack module and signal goes in and then comes out the other side. So the signal from the oscillator over there is going into the Demora, and then it's getting added to the CV that's coming out of here. So I don't know if you can see here, we have on the pitch output, it's not a steady line, it's very much a wavy line. But if I pan that up, if I do something with that, can I make it look more like a sine wave? Yes, I can, look. So that's actually what we're getting on that output, not a steady CV that we want. We're getting this wobbly nonsense because I'm getting this input imprinted upon that output. There doesn't seem to be anything I can do to interrupt the input to output connection on the Demora. It doesn't matter whether I've got monitoring on here or not, whatever I've done, this gets monitored through the output. So I'm just going to have to live with it, and that unfortunately makes the results somewhat weird. However, with a little bit of fiddling and getting the right sort of level, that kind of thing, I do have properly tuned a couple of octaves of stuff going on. So of course, this being Bitwig, I can just hit and start recording. And of course, I've now got all the facilities of Bitwig to apply to my sequence. So I could do things like double the content. Or I could scale it to be smaller like that. And then maybe double the content. What I could do in here is select all these different notes and then create a copy of them. Like so. I'll do that again. Scale it up 200% so then it goes a lot slower. Or just simply add notes. Could reverse it. transpose it down, transpose it up. Or of course mess about with it however I want, because I'm sequencing from Bitwig through the CV instrument into my Eurorack. And that's completely awesome. But what I can't do now, of course, I can't send another CV out to control anything else. I can't modulate anything else because I've only got the two outputs. If I had an audio interface with more CV outputs, I'll be able to do a lot more from Bitwig to these devices. And I think I've shown, at least I hope I've shown, how phenomenally easy it is to do stuff from Bitwig to your modular with these two little devices. I mean, if I don't care perhaps about gating, I could take that out. Where's that going into there? Then I could put that out to number 2. Add my classic LFO, because I feel safe with that. Add a bit of that. Stick that to my filter again. Or something like that. So even with the slight weirdness going on between these, the input and the output, it's still functioning, it still works, because CV is so, manipulable, it's so resilient to things. With MIDI, if something goes wrong, it's all just pear-shaped, but with CV, you can get stuff out of it even when it's not really working properly, because you're still interpreting those voltages and it's just all analog stuff going on. It's all a matter of degree of working as opposed to whether it works or doesn't. So that is using Bitwig and its CV generators to control your Eurorack via a DC coupled audio interface. I'm going to be doing another video on AC coupling, using a regular audio interface, using something a bit more like this to control your Eurorack. It requires some different stuff going on, and so I've made a whole other video about that, so please do go and check that out. But if you want the most trouble-free connection between DAW and Eurorack, then a DC coupled audio interface is definitely the way to go. And even this one here, which doesn't work perfectly, can demonstrate that it can do a heck of a lot and open up whole opportunities of connections between your DAW and your Eurorack. If that's what you want, this is the way to do it. Now, a question this raises, of course, is can you do this from any DAW? Is it only Bitwig that you can do this with? Well, with Bitwig you have these specially designed CV devices within Bitwig itself that enables this generation of CV that then goes out to your modular. A normal DAW cannot generate those signals. It has no tools in which to generate control voltage. However, there are bits of software that can, for instance Reactor or CV Toolkit or Audulus, I think it's called. Other bits of modular software do have this facility. There's also a range of plugins by expert sleepers called Silent Way, and they provide a whole raft of tools for generating CV, LFOs, weird stuff, instruments like this. All of that is bundled together in the expert sleepers Silent Way bundle of plugins. And I'll have a look at that at another time, but for this video I'm just focusing on Bitwig. So if you have another DAW and you want to do this kind of thing, then check out the Expert Sleepers Silent Way plugins and you can do a very similar thing. But in Bitwig I've found that these are just so ridiculously simple that even I can get my head around how to do something creative with them. And that's all I'm after. I'm just after an opportunity to do something creative. And these ones in Bitwig certainly allow me to do that without the headache of having to understand every single thing about them. Modulators to knob, CV to Eurorack. Simple! And in the meantime, go make some tunes.